Today we're going to look at a couple special rational functions. Now the first one should look familiar to us. We did this one at the beginning of the year. We called it that special case absolute value function. And this one's pretty easy to do. There's really not much to do for graphing it. If you remember it, it's pretty easy to do. Recall, if I were to split this one up because of absolute value, I would get two equations. I would get x over x, or I would get negative x over x. And this one, of course, becomes 1, and this one becomes, of course, negative 1. So what that's telling me is that the function is either 1 or negative 1. And if I wanted to graph this, the y value is either going to be positive 1 or negative 1. Now the only question is, when will that occur? To that we have to look at what the absolute value tells us. Well, the first thing is we can't divide by 0. So if something's happening at the 0 here, so it's going to make these open since x cannot be 0 itself. Now, we say it's going to be 1. Well, absolute value is positive when x is greater than 0. So when x is greater than 0, we're positive. Absolute value is negative 1 when x is, of course, less than 0. And that's what our graph looks like. We did these at the beginning of the year. So to graph these, very simple to do. Like if I take a look at the first one, it's the same thing. It's basically, if I get rid of the absolute values, remember this is x minus 1 over x minus 1, which is just 1 itself. So we know it's either going to be, again, 1 or negative 1. Again, I get the negative 1 because of absolute value. Now, what's different from the original parent one is what can't x be. We do have a domain restriction. X cannot be 1. So at 1 is where we start this time. Put a hole here and a hole here. So it's positive to the right, negative to the left. And there we have our graph. So go ahead and try number 2 here real quickly here. Or pause it, and we'll start it. All right. So if we try number 2 now, same idea. Again, get rid of the absolute value. It's either going to be x plus 5 over x plus 5 is just 1, but because of the absolute value, we can get positive 1 or we can get negative 1. Now, what's our domain restriction here? X cannot be negative 5. So I start at negative 5 in this case. Put my holes here. Now, we put the holes there because it cannot be negative 5, and those are holes. So to the right, positive, to the left, negative. So as the question, what will the 2 do to our graph? Well, if you ignore the 2, again, this is going to be either 1 or negative 1. But the 2 is stretching it. It's like our horizontal, it's like our vertical stretch. So the 2 is going to make it either 2 or negative 2. And everything else is the same. Our domain restriction, x cannot equal negative 1. So at negative 1 is where we start. And to the right, positive. To the left, negative. Easy breezy. Just like we did at the beginning of the year. Try number 4. It's a negative. This is like our vertical reflection. That's going to flip it. So if you ignore the negative, same thing. It's either going to be plus or minus 1. So either positive 1 or negative 1. Our domain restriction, just like the first one we did, x cannot be 0 here. So we have our holes here. Now, let's talk about the vertical reflection. Very simple to do. Remember, if this was positive, right, up here, remember 1 was positive to the right. If I flip it vertically, now this goes to the right. Remember, this was originally to the left. Down here at negative 1 was to the left. If I flip it vertically, it puts it up to the top. So it just flips our graph. Very easy to do. All right, let's take a look at some little bit more challenging ones here on the back. All right, this is a special function right here. We've probably seen it before, maybe on a couple of our homework problems. We haven't talked about it yet. But this is a very special one example right here, because what tends to happen is it's a rational function, but if I tend to try to solve for a domain restriction, we get x squared cannot equal a negative 1. Well, here's the problem. If I try to take the square root of it, nothing happens. So what does this tell us? There are no domain restrictions on this one. No domain restrictions. So if I try to find a hole, none. What if I try to find a vertical asymptote? Well, there's no domain restriction. Remember, holes and asymptotes come from your domain restrictions. there is no vertical asymptote here. Now, there is a horizontal asymptote, and the rule still applies. Top is less than the bottom, so therefore it's y equals 0. I still want to find out if it crosses. So I go 0 equals 1 over x, 1 plus x squared, so 0 equals 1. Not true. There's no slant asymptote, so I get a point. What's the point? Okay, so I get 1 point. So let's take a look at the y-intercept. Let x be 0. We get 1 over 1 plus 0, so it's 0, 1 for my y-intercept. Now, what about the x-intercept? Well, that's kind of like saying y equals 0, so you don't have to worry about the x-intercept here. So what will this graph look like? Well, like yesterday, we have an asymptote. Find your asymptotes. There's only one, y equals 0, and we have a point, only 0, 1. The only asymptote we have is the y equals 0, the x-axis. The only point we have is 0, 1. Now, what will this graph look like? Well, remember, functions are attracted to asymptote. It's going to go towards the asymptote. Now, be careful. Most of you guys are going to want to kind of like do it this way, and that's normal. We understand that, but you want to try to avoid that. In this case, it actually bubbles over. It's kind of like make a bubble, like so. And on the other side, it's going to do the same thing. It bubbles and kind of goes like this. Now, for those of you in statistics, this should look a little familiar. It's our bell curve. It makes a bell. So let's take a look at number 5 here, see if we can try one of these. Okay, so what's our domain restriction? Try to solve it. Always try to solve it. So x squared cannot equal negative 2. No domain restriction. So that's what means no holes, no vertical asymptotes. There will be a horizontal asymptote. The top is less than the bottom. I'm sorry. Oh, I had that backwards up here, didn't I? Yeah, I had it right. The top is less than the bottom. So it's y equals 0. Again, see if it crosses. Take 0, set it equal to your equation, 2 plus x squared. Now, tomorrow you're going to have a bonus. When you come in here, you're going to have a bonus. It's going to be almost the exact same thing, but it's going to cross. Oops, I think I gave away too much information. 0 cannot equal 3, so no, it won't cross. Find the y-intercept. Let x be 0. F of 0, we get 3 over 2, basically, because that's just 0. So we get 0, 3/2. 3/2. All right, next we find our x-intercept. We didn't find it for the last one, but I want to show you it won't work here. Because if I let this equal 0, I get 3 over 2 plus x squared. 0 can't equal 3 if I cross multiply here. So we're done. So how do I graph it? Same way. My one asymptote, again, is y equals 0. My 1 point is just a y-intercept, 0, 3/2. So graph my intercept, my asymptote. My 1 point, 3/2. And remember, functions are attracted to asymptotes, so it's going to kind of go wee, and it bubbles up. And there's our graph. Just like this. It's very kind of cool to see. So you're going to have a bunch of these to graph tomorrow as well. All right, now, come back to part 2, and we're going to take a look at one more special function that we're going to be looking at, okay? Thank you.